Hey everybody, it's Miss Berry. In this video today, we're going to talk about section 3.4, which is called Other Common Functions. At this point, we have learned about linear functions and quadratic functions. These are just two types of common functions. Today, we're going to talk about power functions and piecewise functions, which are two other types of common functions. So power functions, what is a power function? A power function is a function that has the form f of x equals a times x to the r, where a and r are real numbers. Okay, so a and r are two fixed real numbers. That means they are not going to change. So some examples might look like this, like 2 times x to the 5th, or it could be something even more simple, like f of x equals x cubed. All right, so really the defining characteristic of power functions is that you're just going to have one term. You're not going to have anything being added on or subtracted. You can have a number in the front, that's a. A is called your coefficient. Something that is not a power function that maybe looks really similar is something like this. Let's call this g of x. Something like this. Let's say x, or excuse me, let me erase that. That's not what I want to do. G of x equals 2 to the x. So this kind of looks similar. And you think, oh, okay, it has a variable up here in the power. Maybe that's a power function. This is not a power function because power functions have fixed powers. All right, so their exponent should not be changing. And here your variable is in the exponent, which means that your exponent would be changing. So the exponent needs to be a fixed number in order for it to be classified as a power function. So again, power functions are pretty simple. They're just functions that are being raised to some fixed power, and you're not going to see terms being added on, like you're not going to see a minus 7x or something like that here. They're just very simple one-term functions. All right, so let's take a look at the graphs of some power functions, and then we will talk about how the graph is affected by what your coefficient is and by what the power is. All right, so let's start with f of x equals x to the 4th over 5. Now it's kind of hard, just the way it's written right here, it's kind of hard to see what the coefficient is, but you could write it a little bit differently. You could say, okay, well, I'm going to pretend like there's a 1 there, and then write this as 1 over 5 times x to the 4th. So now you can clearly identify, you can say, okay, well, the coefficient here is 1 over 5, and my power, or my exponent is 4. All right, so I'm just going to make this easy on myself, and I'm going to graph it in my graphing calculator, and then I'm going to sketch the graph. So I'm just going to go to my y equals screen, clear out anything I have in there. Okay, and then I'm going to type in my function. You can type it in either way if you want to do 1 over 5 x raised to the 4th. That's fine. You could also type it in just the way it originally appeared, which was x raised to the 4th over 5. Just make sure if you do type it in that second way right there, make sure that you get out of the exponent. So you don't want to do something like this, x to the 4th over 5. So you can see we're not dividing the entire term by 5. We're just dividing the exponent by 5. So make sure if you're writing it that way that you get out of the exponent before you type that divided by 5 part. Okay, so those are exactly the same. Either way is fine. All right, so before I hit the graph button, I'm just going to take a look at my window, see what my window looks like. Great, I've got the standard window in here right now, negative 10 to 10, negative 10 to 10. So I'm going to go ahead and hit graph. I like to start off in my standard window, and then if that standard window doesn't work, then I can try something different. All right, so here's my graph. You can see it sort of looks like a parabola. It's a little bit different, looks a little bit wider than our normal parabola. So I'm just going to sketch the graph. I can, if I wanted to make it more precise, I could go to my table right here. So I could hit second graph to go to my table. And then I could pick out a few coordinates. Let's get some reasonable ones here. 0, 0. We'll plot that one. Let's get a different color. 0, 0. All right, then we have, let's do 1.2. So 1 and then 0.2. Negative 1, 0.2. And then right here, negative 2 is negative 2, 3.2. So let's see. Negative 1, negative 2. 1, 2, 3.2. Just a little bit above 3. And then here, 2, 3.2. So 1, 2. 1, 2, 3, a little bit above 3. All right, then I'm going to connect those. I made my first dot way too big. Let's make that look a little bit neater. Oh, man. Erased more than I wanted to. That's okay. All right, so now we're going to connect those. We're just going to do the best we can. Doesn't have to be perfect. In fact, I can even use my highlighter just to give myself a little bit more grace here. So it, yeah, I'm already off to a bad start. Let me try again. All right. Yeah, totally missed that one. Totally missed this one. You can get the general idea of what it looks like. I'm the worst at connecting the dots on these graphs. Yeah, nope, that doesn't look any better. All right, so we're just going to accept the fact that my graph doesn't look great. Give it third time's the charm. All right, not too bad. Okay, that's definitely the best of all 3 tries. All right, so hopefully your graph looks a little bit better than mine, but if it doesn't, that's okay. All right, so let's take a look at one more power function. All right, this one's got an odd power. It's being raised to the 3rd power. It's got a negative coefficient out front, and it's an integer instead of being a fraction. All right, so we're going to go back to our calculator over here. Go to our y equals screen. Clear out what we've got in there. Negative 2x raised to the 3rd. All right, get out of that exponent. We just checked our window. We know we're in the standard window, so we don't need to check that again. We can go straight to the graph. And there it is. All right, so again, you can just sketch it if you want to. Doesn't have to be perfect. If you would like to get a better idea of the numbers, you can go to the table. So second table, and then we can pick some points. 0, 0, 1, negative 2, 0, 0. Let me get back to my pen here. All right, next point. 1, negative 2, 1, negative 2. And then up here, negative 1, 2. So negative 1, 1, 2. All right, and then my next point is going to go off of my graph, I think. Let's see. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. All right, so I'm going to try to get the general shape of the graph just using these 3 points. Let's see. That's not too bad. All right, even though I missed that middle point completely. All right, so that's just some examples of power functions and their graphs. We'll talk more about the graphs of power functions, I think in chapter 5. So this will come back up and we'll talk about what's called the end behavior table. All right, so let's take a look at piecewise functions. That's our last topic of this section. There are lots of other types of common functions. You can talk more in depth about power functions, but I'm just going to give you just a quick overview of both of these. Okay, so a piecewise function, your book calls it a piecewise defined function, but just calling it a piecewise function is fine. Piecewise function is a function that's defined in two terms or more. So they're really easy to spot because they have a very distinct look to them. So they'll always have like a big curly brace here, and then they have at least two parts, could be more. So we'll just put here at least two parts, could be more. All right, so this is where you're breaking your domain up into several pieces. That's why they're called piecewise functions. So you're splitting the domain up. We'll just jot this down. So you're splitting the domain up into several pieces. And giving each piece its own function. Okay, so remember domain, that's your x's. So imagine you're taking your number line and you're going to split it up into pieces. This one's got 3 pieces. 1, 2, 3. All right, so you're taking your number line and you're splitting it up into pieces. And then each piece gets its own function. So maybe this piece in the middle gets x squared. This piece over here, maybe it gets negative 3x plus 4. And then this piece over here, it could even be just a number. Maybe it gets the number 5. So then you would take and you say, okay, well, I need to determine the interval for each one of these pieces. You would figure out this interval, write it down, figure out the middle interval, write it down, and then your last interval, write it down. And then you would say, okay, well, on this interval, the function is going to be just a straight horizontal line at 5. On this middle interval, I want it to be a parabola. And then on this last interval, I want it to be a line. So you're just taking your domain up and you're splitting it, taking your domain and splitting it up into pieces, and then each piece gets its own function. All right, so let's take a look at a piecewise function. So it says, consider the following piecewise function. You may have to pause the video to write this down. It says f of x equals, and then we've got that distinctive curly brace. It says negative 2x minus 2 if x is less than or equal to negative 1. So that means if you have an x value that's less than or equal to negative 1, this is its function. This is the function that it's defined on. And then if x is greater than negative 1, we're going to give it its own function. It's going to be x squared. So this has got 2 pieces. It could have more. It could have 100 pieces. As long as it's at least 2 pieces, then it's called a piecewise function. All right, so here on A, B, and C, we're just finding function values. Not terribly complicated. Your book goes into graphing piecewise functions, but I'm not covering that in this section. So let's look at finding function values. Pretty easy to find the function values here. It's not terribly complicated. It says find f of 3. So f of 3. So this is your x value. This is your x value. So you go up here, you look at your pieces of your domain. You say, okay, well, which piece of the domain does 3 belong in? Is it less than or equal to negative 1? No, it is not. It is not less than negative 1. It is greater than negative 1. 3 is a bigger number than negative 1. So that means we're using this bottom piece. All right, so since 3 is greater than negative 1, we use the bottom piece. All right, so now we're going to take and plug 3 into the bottom piece. All right, so f of 3 equals 3 squared. Just replaced x with 3. 3 squared is 9. That's it. All right, so part B. Let's do this again. Find f of negative 3. Again, that's our x value. Then you got to ask yourself, which piece of the domain does this belong in? Is negative 3 less than or equal to negative 1? Yes, it is. Negative 3 is less than negative 1. So we're going to take negative 3 and plug it into the top piece. All right, so negative 3 goes in for x. So that's going to be equals negative 2 times 3 minus 2. All right, well, that's negative 6 minus 2, which is negative 8. All right, and then last one, Find f of 0. Again, 0 is your x value. Determine which piece of the interval, which piece of the domain 0 belongs in. Is 0 less than -1? No, it is not. 0 is greater than -1. So you're taking 0, plugging it in for x in the bottom piece. All right, so that becomes f of 0 equals 0 squared, which is 0. And you're done. All right, so that's everything for this video. Please let me know if you have any questions. And otherwise, I'll see you guys next time. Have a good day.